All right, so we have this problem. Let's go ahead and take a look at it. We did this in class today. Okay, I'm going to write stuff down kind of as I go. Remember, this is an AP problem. That means that the pictures lie, but the words don't. Now, the words may try to trick you, but they don't lie. The pictures can lie. They can be not to scale, there can be stuff. So don't trust the pictures, just trust the words, but read the words carefully. All right, so a small block of mass M, it looks like this guy up here, is released from rest at the top of the curved, frictionless, that seems important, ramp as shown above. The block slides down the ramp, moving with a speed of 3.5 v naught. Okay. When it collides with the larger block of mass 1.5 m at rest at the bottom of the incline, the larger block moves down the ramp moves to the right at a speed of 2 v naught immediately after the collision. Okay, so we've got a lot going on here, but this is the important part. Express your answers to the following questions in terms of the given quantities and fundamental constants. Okay, given quantities, they mean quantities in this paragraph, not this lying picture up here. So let's look. It's usually something in cursive. Remember, we just want the letter, nothing in front of it. So let's look and see. Okay, I see V naught here. I see an M. All right, that's V naught again, so probably the same thing. All right, so it looks like we have four. I'm going to write this over here. This is really important. I've got M and V naught, and then it says fundamental constants. And remember, the fundamental constant we use the majority of the time is G for acceleration due to gravity. So those are the letters that you've got. See this H? That's not in this paragraph. It says nothing about H. Don't mess with H. All right, so we kind of have that set up. Let's see. Kind of look at the situation. They did tell us some stuff like your velocity. I'm going to do this. I'm going to do just this one in red. So the velocity right here of this cube is going to be v equals 0 at the top. And down here, what did it say it was? 2v naught. All right, I'm going to do this one in blue. This guy down here, the 1.5. Now look, this is not like a 1.5 kilograms thing. What this is saying is this is 1.5 times larger than m. All right, so let's look. You're going to have a collision. So before the collision, this is going to be v equals 0. And then after the collision, I'm going to put after. Okay, v equals, of this one, don't look like you know. What did it say after the collision here? Oh no, you do know. Okay, it starts at rest, and then after the collision, it is 2v naught. And up here, I am so sorry. This right here is supposed to be one line. 3.5 v naught. All right, so that kind of sets things up. And remember, this is the blue and this red one. Okay, so now this is what I do. I just showed a few of you this in class, how to set this thing up. So what you're going to want to do is go A, and let's look at what you need. Determine the height h, I guess that's why they put the h on there, of the ramp from which the small block was released. So I'll put h, that's what they asked for, and the letter they asked for, and also there's no new information. Now where do I get this? I'm going to put this over here like part A. That's where I would get it from, is this area. Okay, so let's look at part B. What I'm making here is just a checklist for what you're doing. This needs to be scratched out at the end. So for part B, you're going to have determine the speed of the small block after the collision. So for B, speed of small after collision. That's a speed of, as long as you know what it says, it's fine. And let's look. That would probably be somewhere around in here, where I would need to look for that information. Now this next one, you need to read this carefully. Read this like you're somewhere you didn't tell your parents you would be and they just sent you a text message. You would read that message very carefully. Okay, the large block slides a distance d before coming to rest. Okay, so it gave you some new information there. It says the large block is going to travel a distance of d. I'm going to put that over there for like we need to have that information. And it says it's going to travel, and I'm really glad I saw a lot of you doing this in class, a distance of d. All right, now it tells you to determine, so it's telling you something to do, the value of the coefficient of kinetic friction, mu. It's how frictiony the surface is, no units. So you've got to find mu between the larger block and the surface on which it slides. Where is the surface on which it slides? It's right here. Watch. Mu. See, I'm just drawing mu. It creates rough surface. We know where to look. This is for part C. So we know it's going to slide here. And at this point, we don't care what the smaller block is doing. And then, but we got that new information of D. So that now means that that can be in your equation, or in your answer. Okay, so now let's look at part D. They love to do that, by the way, to do like something like this right before part D, just to make things difficult. All right, indicate whether the collision between the two blocks is elastic or inelastic. And don't forget to justify your answer, so I'm going to put collision type. Okay, so see, now I have this blueprint of like how to start this. I've got my like givens. This is like my junk. I took my inventory of it. This is what I'm looking for. Got some new information, like a new given down here. Kind of know where I'm looking for it. Got everything set up.